answer questions. So there's nothing new here. Let's just go through a couple examples in 1.3. I'm going to look at, again, this is why you need a book. I'm not going to write out the whole paragraph question. I'm going to tell you what question it is in the book, and then you can obviously look that up. So this is going to be checkpoint number 1 on page 124 of your book. All right, so basically this question is, it says we have starting salaries of people getting out of college. All right, so we have 3 unknowns here, and we want to come up with all 3. So the trick with these, not a trick, but the way you do these is you're always given enough information to form one equation with one unknown. And then we use the techniques that we just learned in 1.2 to solve that equation. So the trick here is to take the words, turn them into one equation with one unknown, even though we have 3 unknowns in this particular question. So let's first list them with 3 different variables. So I'll call it x, y, and z. These are the 3 things we're looking for. It says starting salaries of an education major. So we have an education major. And we have a computer science major. And we have an economics major. All right, so these are 3 majors. We want to know what the starting salary is for these. Okay, that's what we're trying to figure out. Now we're given some information. It says the median starting salary of a computer science major exceeds that of an education major by $21,000. So this is the education major, that's X, and now we're told that the computer science is $21,000 more. This, Y, is $21,000 more than this. So I can express this as X plus 21, and we'll put everything in thousands and then convert it at the end just so I don't have to keep writing those 3 zeros. Okay, so if this is the starting salary of the education major, we're told in the problem that the computer science major is $21,000 more than this. So now I can express this variable in terms of the x, okay, which is what we're trying to do, get everything in terms of one variable. Now we have the same type of information for the economics major. It says the economics major exceeds the education major by $14,000. So this one is 14 more than this. So 14 more, again in thousands, remembering that we're talking about thousands. So now we have everything in terms of x. X, y, and z, all in terms of x. That's always the key for these problems. And then we're given one more sentence that allows us to form an equation. It says combined, they equal 140,000. So when we add them all up, we get 140,000. So now I'm going to put in my x plus 21 for y and my x plus 14 for z, and I'm going to have one equation and one unknown. So I got x, and the y we just said is x plus 21, and the z is x plus 14, and we know that's going to add up to 140. So now we're right back to section 1.2. Nice, easy, one variable equation. We add up the x's. X plus x is 3x. 21 and 14 is 35. And we got the 140 on the other side. We subtract 35 from both sides, and we get 105. And then we divide both sides by 3. And what do we get, 35? 35. Or $35,000. So then, just finish the problem and label everything you were asked to find. We were asked to find the median starting salary of the education major, the computer science major, and the economics major, given this information and this information. So now finish it off and say the education major starting salary is $35,000. The computer science is 21 more than that, so $56,000. And the economics major, 14 more than the 35, so 49. All right, circle it, label it. That's how we want to see these types of questions done. All right, so again, the idea is, in this question we had 3 unknowns. We were given enough information to express all 3 in terms of one variable, and then form an equation with that one variable, solve for that one variable, and then go back and solve for the others. And so that's what we're doing in this section. Just taking what we've learned and applying it to word problems. So we'll do another one here, little different type. This is going to be checkpoint 3 on page 127. All right, and in this one, you're choosing between 2 texting plans. You're going to choose the one that's cheaper. All right, so we got 2 plans. We'll look at the information of plan A and the information for plan B, and then we'll compare them. So it says you're choosing between 2 texting plans. Plan A has a monthly fee of $15 and a charge of 8 cents per text. Okay, so $15 per month plus, what did I say, 8 cents per text. So 8 cents per text. And plan B is only $3 monthly fee, but the text charge is 12 cents. 12 cents per text. All right, so the question is how many texts until the 2 plans cost the same. Okay, so how many texts? So we're going to let X be, so I'm labeling this myself. We've got to label the unknown. This is the number of texts. Okay, that's what we're looking for. That's what we're looking for. Number of texts to where this plan equals this plan. So, we're going to set up an equation here and figure out what this number has to be for these to be equal. So the 15, so plan A, depending if you put this number of text for 1 month, let's say, so we're going to have the cost for plan A is going to be $15.08 per text. Right? That's the cost for plan A for 1 month. For 1 month. And then we're going to compare that to the cost of plan B for 1 month. And that's going to be $3 but 12 cents per text. So now all I got to do is set these 2 equal and solve for x. Right? That's what's going on here. So just do that, 15x plus 8 cents per text. When is that going to be the same as $3 plus 12 cents per text?
15x or?
Oh, thank you. $15 plus 8 cents per text and $3 per text. So this is plan A and this is plan B. So now all we're doing is solving that equation. Let's subtract 3 from both sides first. And then we want to gather the x's. Just sometimes it's easier to keep them positive. So let's bring the 0.08x to the other side, subtracting 0.08x from both sides. So if I subtract 0.08x from this side of the equation, just left with 12. 0.12x minus 0.08x leaves us with 0.04x. And now we just divide both sides by the 0.04. Be careful with your decimals here. 12 divided by 4 is 3, but we got a hundredth here, so we're going to get 300 equals x. So the number of texts that make the plans equal are going to be 300. Again, you can check this, put 300 into this cost, make sure it's the same as when you put 300 into here for this cost. And that'll prove that you've done it correctly. Okay, so what's nice about these videos is, of course, you can always go back and watch them as many times or as long as you need to make sure you get all the information, since we're not live and you're not able to ask questions as I go through it. All right, let's do one more from this section. This is something that I've found in the past students have a lot of trouble with. Let's look at checkpoint number 7. And this is on page 131. Okay, so we've been dealing with one variable, right? We've always dealt so far, other than the very first section where we graphed an equation in x and y, we've been solving for one variable, right? One x here, one unknown in all the questions we've dealt with so far. Now this is a little bit different. Here you're being asked to solve for one variable, but there's other variables in the equation which you can't get rid of. Okay, so checkpoint 7, we're looking at this equation involving capital A, capital P, and lowercase r and t. So there's no numbers here, just variables. And the question is to solve this equation for capital P. Okay, so eventually we want just P on one side and what that equals on the other side. Now, the caveat here is that P appears in two of the terms, right? This term has a P in it, and this one. Now you can't have a P over here, right? You can't solve for P and have a P in the solution, right? So the main goal here is to separate that value that you're solving for so that you can get it to stand alone over here. And that's the most difficult part of these. Well, it's not difficult, but you just have to remember factoring, which is a prerequisite, right? So you got to go back to your factoring and realize that these two terms have that value that you're looking at for, so you want to factor it out of those two terms to get it by itself, right? So this has a P in it, this has a P in it, so now I can come down here and factor that P out of those two terms, right? Basically you're dividing this term by this term. So this term divided by this term leaves you with 1. This term divided by this term, the PRT over the P leaves you with just the RT, right? This is just the reverse of the distributive property, right? P times 1 gives you the P. P times RT gives you the PRT. So we're doing the reverse of that, right? We're not multiplying these two things together, we're factoring the P out of those two terms. Now I can solve for what I want, right? So now to get the P by itself, I just have to divide by everything else. Right? What I do to one side, I obviously have to do to the other side. And then I'm done, right? Because this is just the number 1, right? The same thing over the same thing is always just the number 1, and this becomes my answer. A over 1 plus RT equals P. Okay, so a common mistake here is people will just take this and put it over here, and then they'll say P equals A minus PRT, but that's no good. We cannot have this variable that we're looking for in our solution. We have to factor it out. That's the key. All right, so that is section 1.3. Complex numbers.